Good morning, my dear students. This is the second lecture in the series of Econometrics 2 in a separate playlist labeled as Econometrics 2. The first lecture was based on model specification errors and some diagnostic tests. The present lecture is based on nonlinear regression models. So far, we have been discussing uh, linear regression models and various aspects of classical linear regression model. So the question is, what is the difference between linear and non-linear regression models? When we say our discussion of linear regression models, we state that we are concerned basically with the models which are linear in the parameters. They may be linear or non-linear in variables. Linearity in variables and linearity in parameters are two different things. A model may be non-linear and in variables, but if it is linear in parameters, then in econometrics, we call that model as a linear model. But if a model is non-linear in parameters, no matter this model may be linear or non-linear in variables, then we do not consider that model to be linear. So, in short, we can say if the model is linear in parameters of the model, then we call it a linear model. If it is not linear in parameters of the model, then it is non-linear model. Therefore, we can say that if a model is linear in the parameters as well as the variables, is a linear regression model, and so is a model which is linear in the parameters but non-linear in the variables. It means that if a model is linear in the parameter as well as in the variable, it is a linear model. And a model which is linear in the parameters but not in the variable, still it is a linear model. On the other hand, if a model is non-linear in the parameters, it is a non-linear regression model, whether the variables of such a model are linear or not. However, we must be very careful, for some models may look non-linear in the parameters but are inherently or intrinsically linear models, because with suitable transformation they can be made linear or they can be linearized in the parameter regression models. But if such models cannot be linearized in the parameters by a suitable transformation, by some kind of transformation, they are called intrinsically non-linear regression models. We will discuss both of these models in detail. Uh, Let me remind you, these two exercises have been copied from Gujarati book, chapter 2, and one set of problem is here denoted by A, and another set of problems is denoted by B, and the question is whether the following models are linear or non-linear. Similarly, again, we are concerned with the questions, with answering the questions whether these models are linear or not. So, if you look at model A, in this section it is reciprocal. Model B is a semi-logarithmic model. Model C is inverse semi-logarithmic. Model D is a double log model or a logarithmic model or log model. And model given in E is logarithmic reciprocal. Similarly, this is another model, this is another model, and then C, D, E are another model. So, if you look at these models, some of these models may look non-linear in the first sight, but if you consider them with attention, then they may be intrinsically non-linear, linear. So let us start with this section A. To differentiate between the intrinsically linear and intrinsically non-linear model, let us consider these two exercises from Gujarati book, chapter 2. In exercise A, model A, B, C and E are linear. This is linear, B is linear, C is linear, E is linear, because all these models are linear in the parameters. Now, what about model D? This model D is a type of a mixed bag, because beta 2 is linear. Beta 2 is linear in this model, but natural log of beta 1 is not. But if we transform this model in such a way that we write alpha instead of natural log of beta 1, then this model also becomes linear. And in this model, alpha and beta 2 will be linear. So this set of problems, by transformation, we can linearize these models, and these models are linear. Now let us consider this set of models. So we'll discuss this one by one. In this exercise B, models D and E are intrinsically non-linear because there is no simple way to linearize them. It means D and E are intrinsically non-linear models because there is no way to linearize them by some transformation. If we consider model C, it is a linear model because this model is linear in parameters beta 1 and beta 2. What about model A and B? So here, if you take logarithm on both sides, then this model becomes yi is equal to beta 1 plus beta 2 xi plus ui, which is linear in the parameters. Hence, model A is intrinsically a linear model. Model B is an example of a logistic distribution function, and we will discuss this in detail. On the surface, it seems that model B in the exercise B is non-linear regression because it is logistic probability distribution function. But a simple mathematical trick may make it a linear regression model, namely, if we do this mathematical trick, and if you take the ratio of the natural log of 1 minus yi divided by yi, then this model will become linear. Therefore, model B is intrinsically linear also. So this is how you differentiate between intrinsically linear and intrinsically non-linear models. Now consider the famous Cobb-Douglas production function, which is given by yi is equal to beta 1 x2i raised to the power beta 2 x3i raised to the power beta 3 e raised to the power ui. In this model, y is the output, x2 is the labor input, x3 is the capital input, and we may rewrite this model in a different way by taking a natural log on both sides. Now this model will become linear. Now these two can be uh, changed by taking natural log on both sides of equation 2. We get equation 2.a. Here alpha is equal to natural log of beta 1. Thus in this form the Cobb-Douglas production is intrinsically linear. We may consider another version of Cobb-Douglas production function in which when there is no difference between 3 and 2, except in equation 1 the disturbance term is the exponent of the e, or the power of e, whereas in equation 3 the ui enters this model linearly. So if you take the natural log on both sides, then we have natural log of yi, which is equal to alpha, where alpha is the natural log of beta 1 plus beta 2 natural log of x2i plus beta 3 natural log of x3i plus natural log of ui. This model is linear too in the parameters. We may now consider another version of the Cobb-Douglas production function, and here the error term enters this model additively, and if you take the natural log of this model, we may see it differently. But as we have noted, Cobb-Douglas production function version 2.a and 3.a, which are intrinsically linear, that we discussed earlier. But there is no way to transform model 4 or the function 4 so that the transform model can be made linear in the parameters. So it means that this equation 4 is intrinsically nonlinear because there is no way to make it linear by some kind of transformation. Therefore, model 4 is intrinsically a non-linear regression model. Now, the hint is, if you try to log transform model 4, it will not work because natural log of a plus b is not equal to the natural log of a plus natural log of b. That is why model 4 cannot make the log linearized. So this means that model 4 is intrinsically a non-linear regression model. Another well-known but intrinsically non-linear function is the constant elasticity of substitution function, that is CES production function, of which the Cobb-Douglas production function is a special case. And the constant elasticity of substitution production function is given by this equation number 5, where yi is equal to a sigma ki raised to minus beta plus 1 minus sigma times li raised to the power minus beta whole raised to the power minus 1 divided by beta. Now this constant elasticity production function cannot be made linearized by any transformation. So this production function is intrinsically a non-linear regression model. And in this function, y is the output, k is the capital input, and l is the labor input, a is the scale parameter or efficiency parameter, this sigma, this is the distribution parameter, beta is the substitution parameter. No matter in what form you enter the stochastic error term ui in this production function, there is no way to make it linear in parameter regression model. So we must keep in mind always that the constant elasticity of substitution production function is intrinsically non-linear regression model. Ladies and gentlemen, this is a brief introduction and the difference between intrinsically linear and non-linear model so far as the estimation of non-linear models is concerned. I'll share some videos with you that are concerned with how to estimate non-linear regression. Thanks for watching this video. If you haven't yet subscribed to the channel, kindly subscribe to the channel and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll upload for you. Kindly